Hello students, welcome to my channel Civil Cap, and previously we have studied the three moment equation. Today in this class we'll deal with numericals related with three moment equation. So let's get started. Let's take our question in which we have two beams and three supports. As we know that we can apply the three moment equation as to the structures having two beams and three supports, or the given question here be a UDL loaded throughout two beams and having three supports, and the length of the first beam be 6 meters and the length of the second beam be 8 meters. So our first step is to draw bending moment for the given structure. So we should know that for a beam carrying a UDL will have parabolic form. Similarly, this beam also carries a UDL, so this will also give me a parabolic structure. So we will assume that the area of this parabolic portion will be A1 and this will be A2. As we have studied in the previous video that the CG of this particular parabola from end A, let us name it as A, B and C, be small a1, and center of gravity of this parabola be A2 from end C. Now we will find the maximum ordinate in this parabola and similarly the maximum ordinate at this parabola. So first of all, let us consider free moment diagram for the span AB, and let us find it maximum ordinate. So here for this my maximum ordinate will be WL square by 8, as we know that maximum ordinate for a parabola is WL square by 8. So here as we know that the W is 40 kilonewton loaded in the beam AB, so we'll take W as 40, L is the length of the beam, that is 6 meter. We'll take our W as 40 kilonewton per meter and L as 6 meter, as in our first beam AB having length 6 meter and loading of UDL of 40 kilonewton per meter. So now let us put the values in our equation, which will now give me 180 kilonewton per meter. So this is the value of the maximum ordinate for the beam AB. Again similarly I will draw free bending moment diagram for the span BC, that is this beam having UDL of 40 kilonewton and span length of 8 meter, and find its maximum ordinate. So as it is loaded with the UDL, so it will give me same value of parabola, that is WL square by 8. Here my value of W will be same, that is 40 kilonewton per meter, and length will be 8 meter as given in question. So now I'll put the values in my equation and find the value that will give me 320 kilonewton meter. Now my next step is to find area of the parabola, so that I can put the value of capital A1, capital A2, small a1, small a2 in the formula of three moment equation. So accordingly I will solve for area and center of gravity from end A. Again I'll solve area of, let me name it as capital A1, small a1, area A2 for parabolic diagram of beam BC, and let this be the area of parabolic area for the beam AB. Again I will find CG from end C, that is A2. So now we should know what is the area of parabola. So by mathematical calculation we know that area of parabola is equals to 2 by 3 L into D. Now I'll apply this formula here, that is 2L by 3 into D, and putting the values from my beam. As we know that the value of L for the first beam AB is 6 meter, and depth, that is the maximum ordinate of the parabola, that is 180. Again I will solve for CG from the end A. So as I have a parabola for the first beam AB and its distance from end A is A1, that is simply I can say that it will be the half distance of my length. So my length is 6 meter, therefore A1 will be 3 meter, that is 6 by 2, it is equals to 3 meter. So my CG for the first A1 is 3 meter. Again for the second parabola, that is for the beam BC, my parabolic area will be 2 by 3 into length into depth, that is 2 by 3, and L for this particular parabola is 8 meter. So my length will be 8 meter, and depth, that is maximum ordinate, what I have found is 320. So after solving I'll get 1706.67 by solving this equation. So again I have to find the CG distance from the end C. So this is the C end, and I have to find A2. Again I have discussed that A2 is equals to L by 2, that is equals to 8 by 2, which will give me 4 meter. So this will be my CG of the end C. As in question there is no specification given for my sinking of supports, that is deflection of supports A and C, therefore I will take the deflection at A and at C, or sinking of support equals to 0. If mentioned in question or given any particular value, then I have to take the values of HA and HC, otherwise I will take it or equate it equals to 0. Again in my question the value of I is not specified. If the moment of inertia for both the beam is not specified, then I will take the moment of inertia for both the beam equals to I. Now in the beam A, B, C as given is a simply supported beam. Now we know that for simply supported beam the moment at ends are equals to 0. That is, here I will consider, as I have beam like A, B and C, so moment at this end and this end, both the moments will be 0. So I will consider here moment at A, that is MA, and moment at C, that is MC, will be equal to 0. Now my findings for moment equation are completed. Now I will directly put all the values I have evaluated in 3 moment equation. So now I'll write 3 moment equation. As we have already found out the equation of 3 moment, that is MA L1 upon I1 plus 2 MB L1 upon I1 plus L2 upon I2 plus MC L2 upon I2 is equals to minus 6A1 small a1 I1 L1 minus 6A2 small a2 upon I2 L2 plus 6 EHA upon L1 plus 6 EHC upon L2. So this is my three moment equation, and the values what I have found I'll write for you. MA is equals to MC is equals to 0, I1 is equals to I2 is equals to I, HA is equals to HC is equals to 0. Now what I have found is A1, capital A1, that is 720, small a1, that is 3 meter, capital A2 is 1706.67, small a2 is equals to 4 meter. These are the values I have found, and what I know is L1 and L2, that is 6 meter and 8 meter. So by using these values I'll put all the values in the above equation, and the value of unknowns will remain same as they are. So let me put the values. MA is equals to 0, L1 is equals to 6, I1 is equals to I plus 2 MB. MB, I have not defined any value for MB, so it will remain same. Now L1 is equals to 6, I1 is equals to I, L2 is equals to 8, I2 will be again equals to I plus MC is equals to 0, L2 is equals to 8, and I2 will be I again, which is equal to negative 6 into A1, that is capital A1. Capital A1 will be equals to 720 multiplied by CG from distance A, that is 3 meter, upon I1 will be I, and L1 is equals to 6 meter. Again minus 6, A2 will be 1706.67 multiplied by the distance of CG, that is 4 meter, upon I2 will be equals to I, and L2 will be equals to 8 meter, plus 6E is not defined, and HA is equals to 0 upon L1 6 meter plus 6E into HC is again 0, and L2 will again be 8. So after simplification I'll get values 2 MB 6 upon I plus 8 upon I equals to minus 6 720 into 3 upon I into 6. Again 6 into 170467 multiplied by 4 upon I into 8. Rest this part of the equation, and this part of the equation, and this part of the equation will equal to 0. That means as it is multiplied by 0, so this all will be equal to 0. So by simple mathematics or by cross multiplication, I will finally get the value of MB as 260 kilonewton meter. So this is the required moment at the support B, what I have to find out using the three moment equation. Now my final step is to draw the bending moment diagram, what I will draw by merging both free body diagram and my evaluated value of MB. So my first parabola is like this, what I previously drawn, and my second parabola for the beam BC will be like this, as I have already evaluated the maximum value as 180 and 320 kilonewton meter. Now it is A, B and C. At B, I have got the value as 260, which is greater than 180 and less than 320. So it will be somewhere here, that is 260, but the value is in negative. So as the moment at A is 0 and moment at C will be 0, so I'll join it like this. And as this is in negative, so the similar portion will be reduced. So this is my final bending moment what I have got. In this way I can find out or apply the three moment equation in particular beams where I have two beams and three supports. So we end up our video here with this numerical. If you really like my video, then subscribe, share and do comment if you have any doubts in my video.